everybody. Well, let's start off by saying hi to Murphy. And then we've got to find Ava over here. So say hi to Ava. Hi, Ava. Okay, so now that's taken care of. We're going to be talking about domain today. And when we're dealing with domain, we're trying to find the... Here's Ava. She followed me over. Hi, sweetie. Good dog. The domain is the set in the definition of the function. Notice my little typo there. I forgot to put that part. That the rule acts on. And the rule you'd know is something like x squared plus 4x or 1 over x. Now, the first domain that you generally deal with is with a polynomial. And a polynomial is like x squared plus 4x, and the domain would be denoted as all real numbers. You make these two bars and you swoop an r in there. And what that stands for is the interval from negative infinity to positive infinity. And functions that have that as a domain have whole numbers as their exponents. So you have x squared plus 4x to the first. Something like this would be x to the negative 1, and that isn't allowed. So 1 over x puts the, or the negative 1 puts the x into the denominator, so it reads 1 over x. And we can't have a 0 in there because we don't know how to divide by 0. Now, a couple other examples that would have that domain of all real numbers is something like f of x equals x, or f of x is equal to x cubed plus 2x squared plus 1. No variables in the denominator, no negative exponents, and we wouldn't have something like x to the 1/2, and if you can recall, that's the same as the square root of x, where the 1 sits there and the 2 sits there, and I call it the brain. You bring it up around and the 1 is up on top. And basically that fractional exponent says for every 2 that you have in that group, 1 gets to pop out. All right, a lot of information right there. So let's just do a couple of examples. So x greater than or equal to 0 is the domain we're thinking of, and that would be the square root of x. So if you take 0 and you plug it in, you could take the square root of 0. If you take 25, the square root of 25 works. The square root of 1/4 is a half. So you can take square roots, even of irrational numbers, just as long as they're positive, okay? My comment with when you take a square root of an irrational number, you'll get an irrational number, or the square root of 2, for instance, it's like 1.414, goes on forever and ever, it becomes an irrational number. You can't have a negative on a number. Now catch what I just said there. You can't have a negative on a number because negative 5 times negative 5, they have to be the same number, and that's going to give you a positive 25, and that's not the same, so it doesn't work. But you can have a negative in a radical, and that, the first time I saw that when I was a student, pretty much blew my mind away. What you have to think about that is you're changing the sign of the number you're plugging in. So if I think about it as that negative is that negative, I'm going to take negative 1 and plug it in. Well, the negative of a negative is now a positive. So I'm now taking the square root of positive 1, which is 1. And so that thing's domain is all values less than or equal to 0. So you can have a negative on a variable. It's a little different, but you have to think about it as what would happen if I plugged in a negative number there, okay? Now, this one's going to have a domain as x is greater than or equal to 1, and it's going to read x minus 1. And what we do is we just think about it algebraically as I have x minus 1 needs to be greater than or equal to 0, because I want to take square roots of positive numbers or zeros. And so we just solve that inequality. So we go, all right, well, x is greater than or equal to 1 after we add 1 to both sides. And you can get more complicated functions. like 4 minus x squared. And again, you just start off with 4 minus x squared greater than or equal to 0. And you really first want to start with, ignore that, that'll come back later, I'll rewrite it when I get there. You really want to figure out where it does equal 0. So you go 4 minus x squared equals 0. And you have two ways you can do it. You can either factor, you still have to set equal to 0, so 2 minus x, 2 plus x. And then you set each piece equal to 0, and you'll get 2 and negative 2. Or you can just take the square root on both sides after you make x squared over. And again, you'll get plus or minus 2. Now what we do is this thing called sign evaluation. So we go from negative 2 to 2. Just write a number line. We go negative 2 and 2 because that's where our zeros are. And we take test points, TP for test point, and we're going to test point negative 3. And that's what I had written in there before. So I take negative 3 and I plug it into that x. So I'm going to have 4 minus negative 3 squared. Well, that's 4 minus 9, and that's negative 5. That is not bigger than 0, so that's a no. Then you try 0. 0 works, and if you take 3, you'll find that again, it's a negative. You test point your negative 2 and your 2, and what you find is that your domain is negative 2 to 2. Okay, so these closed brackets act like our solid dots again. So I'd have a solid dot there, a solid dot there, and all the numbers in between here. So it's from negative 2 to 2, and it includes negative 2, and it includes positive 2. That's the same as saying negative 2 less than or equal to x, less than or equal to 2. On your graphing calculator, what you'd need to do is go to your y equals and type that function in. You have a trace key, and if you hit the second button and the trace, you're going to go to maximum, and you can find the high point. You already know what the low points are by plugging in negative 2 and 2 into your function. And then for your maximum, you're going to see a graph that looks like so, and you're going to have your axes. And what you'll want to do is you'll move your cursor to this side, you'll hit enter, and what will happen above is you'll see this little triangle that's kind of solid. And then you'll move your cursor to the other side of where it peaks out, and you hit enter. And if you're on the 84, it'll ask you to hit enter again, or it'll say guess down at the bottom. Just hit enter again. And then it'll give you a maximum. It'll say x equals something, and then you'll get y is equal to 2. Well, that's the high value. You already know the low value from plugging these in. And so your range ends up being 0 to 2 and including those. And I'm going to encourage you to use the calculator to find the range. I don't need you to do any more than that. Through time, you'll get used to what things look like more and more, and then we can start to have different discussions about range. Now, you'll notice I have some other examples here. So what if you have a rational function? Well, the denominator is what we can't let be equal to 0. So we say x minus 2 can't be 0. Add 2, x cannot be 2. Oh, okay, so if we do interval, we're going negative infinity to positive 2, united with 2 off to infinity. And we don't include those. What happens if we have x squared minus 16? And the thing you got to recognize here is that if you factored that, they cancel. You still have to recognize that the original function is where we deal with our domain. Even if you can reduce out stuff, you still go back to the original function. So we take x squared minus 16, set it equal to 0, or not equal to 0, forgive me. Move 16 over, take your square root, and you get your plus or minus 4. Those are the values you must avoid. And that'd be like saying negative infinity to negative 4, united with negative 4 to 4, united with 4 off to infinity. But it's quicker just to write that. Okay? All right, there'll be more coming.